Yes, good evening, all of you. Good evening, my dear students. Today we are going to discuss solution chapter. Good evening, all of you. Come to the live session. Come to the live session. Yes, good evening, my dear students. Come to the live session. Good evening, my dear students. Come to the live session. My name is Lakshmarana. This is Ellen Brand of Chemistry. Today we are going to discuss about solution chapter. Sir, in the solutions, ideal and non-ideal solutions, positive deviation of non-ideal solutions and negative deviation of non-ideal solutions, then azeotropic mixtures, then also we have to discuss about the colligative properties. So all the topics we will discuss today, then as well as what are the previous year questions are there in it, that also we'll discuss. So look, my dear students, first of all, we are going to discuss that is ideal solutions. What are the ideal solutions that we have to discuss? So listen, before going to start the session, so these live classes are useful for those are preparing for the EAPCET examination. Without any coaching, those are preparing in the home. For them, it is useful. So please share my channel and subscribe my channel. That is very useful. Those are poor students will be there in the villages. For them, it is useful too. So that's what we are discussing. Right? Clear? Yes. So now first we are going to discuss that is solutions in that ideal solutions. Ideal solutions. So what are the ideal solutions? Ideal solutions ante enti? So we know very well what are the ideal solutions. So generally we know that the solutions which follows the Raoult's law, that we call it is ideal solution. But so remember, so while making the solution, so this is solute. A solute will be there. Then plus solvent we are taken. By adding both, so solute, just assume it as a B component, solvent the A component. So once both are added, we can prepare a solution. This is solution. Sir, in this A will be there and B will be there. This we call solution, right? Sir, in this solution, is that ideal solution or not? How can you say? Sir, in the solute, only pure solute will be there. At that time, whatever the interactions are there in between the solute and solute, whatever the interactions are there in the solvent and solvent, that interactions are equals to solute and solvent interactions. So the solution in which Solute or solvent interactions are equals to solute and solvent interactions. Such type of solutions we call ideal solutions. Ideal solutions, nothing but the solutions in which the solutions in which the solutions in which solute solute interactions solute interactions and solvent interactions solvent interactions solvent interactions are equals to solute solvent interactions solute solvent interactions that are called ideal solutions. That is the first point you have to remember. So what is the first point? The solution in which solute interactions, nothing but in between the B, what type of interactions are there? Then in between the A, what type of interactions are there? That both are equal. Even AB interactions with the equal with the AB interactions. That is what I mentioned. Sir, A interactions are equals to that B interactions, that is equals to AB interactions. This is very, very important point for the ideal solutions. Then second point, I told that previous itself, the solution which follows the Raoult's law we call ideal solution. The solution which obeys Raoult's law are called ideal solutions. Ideal solutions. Okay, these 2 points are understand too. You people, sir, what is the Raoult's law? What is the Raoult's law? I know we know that the solution which obeys the Raoult's law we call ideal solution, right? Then what is the Raoult's law? So Raoult's law, it will tell about in case a solution will be there. In the solution, two components are there. Sir, partial pressure of each component is directly proportional to mole fraction of that component. That is Raoult's law actually. The partial pressure of A, it is equals to mole fraction of A into then P naught A. This is Raoult's law. So each component I told, not only for the A component, even the B component if you take. So PB equals to P naught B into mole fraction of B. So this is Raoult's law. So the statement 3 that in the mathematical form we can write it is PA equals to P naught A into mole fraction of A, or look at my dear students, PB equals to P naught B into mole fraction of B, right? Then we can say one more. Sir, P total, it is equals to PA plus PB. That means what? The P total, it is equals to PA, nothing but what will be there? P naught A into mole fraction of A, right? So P naught A into mole fraction of A plus P naught B into mole fraction of B, that is P total. This is all it will be follows. Then still will be there some of the points. That is fourth point, look at. So once a solute and solvent both are adding, just assume it, this will be there at 10 ml will be there. Then this will be there, 10 ml will be there. When both are added, we know that 20 ml will come. Then delta V, the change in the volume upon mixing. రెండిటిని యాడ్ చేసినప్పుడు సేమ్ వాల్యూమే వస్తే అంటే the sum of total volume if you get that is equals to before adding whatever the volume will be there. So that we call change in the volume. Change in volume nothing but delta V mixing. It is equals to 0. Delta V mixing is equals to 0. For example, look at. So how can you calculate the delta V, sir? Delta V mixing, how can you calculate? So here, so before volume, then after volume, when it is calculated, after volume, addition of both. So before adding, after adding. So before adding 10 plus 10, how much is there? 20 is there. After adding also, if you get 20, after adding also, if you get 20, then 20 minus 20, then you can get it is 0. So the volume upon mixing, when it is get 0, the change in the volume upon mixing when it is get 0, such type of solution we call it is an ideal solution. So this statement you have to remember. This statement you have to remember, that is delta V mix equals to 0. Then fifth statement, that is delta H mix. Delta H mix. That means, so solute to solvent, when it is added both, solute to solvent to రెండింటిని యాడ్ చేసిన తర్వాత, యాడ్ చేస్తున్నప్పుడు హీట్ అబ్జార్ప్షన్ కానీ హీట్ రిలీజ్ అవ్వడం కానీ జరిగితే, హీట్ అబ్జార్ప్షన్ కానీ హీట్ రిలీజ్ అవ్వడం కానీ జరిగితే దాన్ని ఎక్సోథెర్మిక్ ఆర్ ఎండోథెర్మిక్ డిజల్యూషన్స్ అంటారు. అలా కాకుండా ఎలాంటి చేంజెస్ అంటే హీట్ అబ్జార్ప్షన్ కానీ హీట్ రిలీజ్ కానీ రెండు జరగకపోతే, then we call it is delta H mixing upon two components equals to 0. That we call delta H mix equals to 0. So this is applicable for the ideal solutions. Then one more. Then sixth one, delta S, it is always greater than 0. Why? Sir, any two liquids or any two gases, when they are mixed, then automatically that will be a randomness of the particles increases. So that's what change in the entropy increases. So change in the entropy increases, delta S is greater than 0, you can represent. So not only ideal solution, man, even for the non-ideal solutions also, delta S is greater than 0. This won't change. Even this won't change. Even one more, delta G is less than 0. ఈ రెండు టర్మ్స్, ఈ టూ టర్మ్స్ ఐడియల్ సొల్యూషన్స్ కానీ నాన్ ఐడియల్ సొల్యూషన్స్ కానీ, లేదా పాజిటివ్ డీవియేషన్ ఆఫ్ నాన్ ఐడియల్ సొల్యూషన్ కానీ, నెగటివ్ డీవియేషన్ ఆఫ్ నాన్ ఐడియల్ సొల్యూషన్ కానీ, లేదా దెన్ వన్ మోర్, సో దట్ ఈస్ ఇన్ కేస్ ఇఫ్ యూ టేక్ మిక్చర్ ఆఫ్ గ్యాసెస్ కానీ, సో ఈ టూ టర్మ్స్ చేంజ్ అవ్వవు. ఎస్, దట్ ఈస్ వన్ ఆఫ్ ద పాయింట్. సో all these we are calling ideal solutions. రిమెంబర్, ఐడియల్ సొల్యూషన్స్ అంటే మనం ఫస్ట్ నుంచి ఏం చెప్పుకున్నాం? సరే, సొల్యూషన్ ఇన్ విచ్ solute interactions, solvent interactions, sir, equals to solute solvent interactions. That is the first point. Then second point we are discussed, the solution which follows the Raoult's law, then we call it is ideal solution. So then mathematically, Raoult's law, how can you express it is? Then in case if you take the solution, this is the two components are there in solution. Each component of partial pressure of each component in the solution is directly proportional to mole fraction of that particular component. So that is what I represented in the mathematical formation like this. Then according to Dalton's law of partial pressure, P total equals to PA plus PB. Then so look at P total equals to P naught A into mole fraction of A plus P B into mole fraction of B. Then one more point I told, that is change in the volume upon mixing is equals to 0. The change in the enthalpy upon mixing also equals to 0. Then delta S value always greater than 0, delta G value always less than 0. So once a delta G value is a less than 0, the process we know that spontaneous process. Remember the spontaneous process. Next, the conditions, there must be remember the conditions for the ideal solutions. One is, so once a solute and solvent both are adding, so both the components should not react with each other. So both solute and solvent should not react with each other. Sir, in case if it is react, that we cannot say the ideal solution. So which does not react with each other, that we can say the ideal solution. So remember the conditions. Condition number one, solute, solute and solvent, solute and solvent do not react with each other. Do not react with each other. రెండిటితో ఇంటరాక్షన్ జరిగితే రియాక్షన్ జరగకూడదు. దెన్ సెకండ్ వన్ సొల్యూట్ does not dissociate or associate in the solvent. సాల్వెంట్లో యాడ్ చేసిన తర్వాత డిసోసియేషన్ అవ్వడం కానీ లేదా అసోసియేషన్ అవ్వడం కానీ, డిసోసియేషన్ నథింగ్ బట్ సో ఏ పార్టికల్ దట్ విల్ బి డిసోసియేటెడ్ ఇంటూ 2 particles or 3 particles. సో 2 పార్టికల్స్గా లేదా 3 పార్టికల్స్గా విడిపోతే దాన్ని డిసోసియేషన్ అంటాం. అసోసియేషన్ అంటే సార్ ఆల్రెడీ ఉన్న పార్టికల్స్ 2 particles లేదా 3 particles అగ్రిగేట్ అయిపోయి అసోసియేట్ అయిపోయి ఒక పార్టికల్గా ఉంటే దాన్ని మనం అసోసియేషన్ అంటాం. సో సొల్యూట్ must not be associate or dissociate in the solvent. Solute do not associate or dissociate in solvent. That you have to remember, my dear students. So all these are applicable for the ideal solutions. So note all these points. In case if you have any doubts, just comment in the comment section, then we'll discuss. Yes, next we have to discuss about the non-ideal solutions. So now we are discussing about the ideal solutions. Based on the ideal solutions, what type of questions are given in the previous examination of EAPCET, that also we'll discuss now itself. So all these points, whatever the points are there, 6 points are these, then 7 points. So which are the conditions are there, that also you have to remember. Then 3 previous year questions are there based on the ideal solutions, that we'll discuss now. Yes. So note down all the questions and whatever the concepts we are discussing, my friends. Definitely that will be useful for you people. So those are preparing for the JEE means, those are preparing for the EAPCET examination. Yes, look at one of the question. It is given in the 2022 July 18th in the shift 1. They are given 2022 July 18th kichina question idi. Based on ideal solutions mida ee question icharu. Elanti type of question. So look at which of the following are correct for ideal solution ani icharu. Which of the following are correct for ideal solutions. Ideal solutions గురించి నేను డిస్కస్ చేసిన 7 పాయింట్స్ మీకు గుర్తుంటే దీనికి ఆన్సర్ ఈజీగా చేయొచ్చు. సో లుక్ ఎట్ వాట్ ఎవర్ ద ఆప్షన్స్ ఆర్ గివెన్. సార్ ఆప్షన్ ఏ, దట్ ఈస్ delta V mix, it is equals to 0. Then option B, V solvent plus V solute equals to V solution. Then C, delta H mix, it is equals to 0. Then D, H2O plus CO2 gives rise to H2CO3. H2CO3 is example of ideal solution. Ideal solution. Then options, option 1 or option A, then A comma B only. Then option B comma C only. Then option C, A comma B comma C only. Then option D, A comma B comma C comma D. Look at all these. Observe it carefully. So for the ideal solutions, sir, whatever the statements we are discussing now, the change in the volume upon mixing is 0, correct? Then V solvent and V solute. I told that in case volume of solvent is 10 ml, just assume it. Then solute also 10 ml. Once both are added, so you must be get 20 ml, exact 20 ml. Either 20.1 or 19.9 if you get, that is not ideal solution. So exact ga equal ga untene, then ideal solution. So it is ideal solution. Then delta H mix, it is equals to 0. Nothing but what I told. Sir, both solute and solvent, when we are adding, there is no evolution of evolution of heat or absorption of heat. It does not take place. Such type of solutions we are calling ideal solutions. Then, so look at fourth one, the D option, observe it carefully. H2O and CO2 both, when it is added, H2CO3 is formed. So that means what happens here, chemical reaction happens in between the H2O and CO2. I told that conditions, so two reactant, that is a solute and solvent, should not react with each other. So that is the condition of ideal solution, right? So this is not the ideal solution, but they are given the example of ideal solution. Only 3 options are correct. So that are A, B, C are correct. So A, B, C only are correct. That is C option. Clear, my dear students? Then one more question also is given. So just listen each and every question you have to read, each and every question you have to study. Then listen carefully. If you have any doubt, please ask in the comment section. Definitely I will reply to you people. Then I will explain once again which question if you have a doubt. Then the second question based on ideal solutions only, that is, which of the following, so wait a minute. So which of the following is a mixture of an ideal solution? Which of the following is a mixture of, which of the following is a mixture of ideal solution? The mixture of ideal solution, that is question is given. The 2021 sir August lo adina question idi. August lo adina question 2021 lo. So options icharu, then option A CCl4 plus, then C7H8, then option B CHCl3 plus, then C6H6, then option C H2O plus CH3OH, then option D N number of what N nothing but normal hexane, N hexane, that is C6H14 plus, then N heptane C7H16, like this is given. Look at, sir, which of the following is ideal solution అని మన క్వశ్చన్ అడిగినప్పుడు, so you have to remember similar structure and as well as similar polarity will be there. Such type of solute and solvent is a ideal solution. Remember, in the nature there is no any ideal solution, but similar structure and similar polarity containing two components can form nearly ideal solution. So here, say CCl4 and C7H8, it is not at all a similar structure. So only one carbon is there in the structure of CCl4, then four chlorines are attached like this. But in the C7H8, sir, seven carbons are there. Seven carbons are when they are arranged in the chain like this or in the cycle. So the both are different structures. Both are different structures. I told that. So note, it is very important. Similar structure and similar polarity. Similar structure and similar polarity containing molecules that are act as ideal solutions. For example, if you take benzene and toluene, both are ideal solutions. See, benzene and toluene both almost the same structure will be there. So this is benzene, right? Then this is toluene. So both are ideal solutions. Then one more example I will give to you, that is ethyl chloride, C2H5Cl, then C2H5Br, ethyl bromide, even that is also ideal solution. Then third one more example, chlorobenzene, the benzene attached with a chlorine. Then bromobenzene, the benzene attached with a bromine, even that is also act as ideal solution. Then here one more example, that is hexane and heptane. So almost the same structures. So hexane, how it will be present actually? So 1, 2, 3, 4, 5, 6. This is the hexane structure. This we call N-hexane. N-hexane. Then N-heptane, how it will be present? Look at. So 7 carbons, 1, 2, 3, 4, 5. Then 6, 1, 2, 3, 4, 5, 6, then 7. So N-heptane. So N-hexane and N-heptane both are present. So these are called ideal solutions. So which are having the similar structures and similar polarity, that we are calling ideal solutions. Okay, clear, my dear students? Then one more question is there based on it. So one more question is there based on the ideal solutions. That we'll discuss. The third question. Liquid mixture is an ideal solution if this question is given in the 2022, then in the July 20, they are given in the second shift. That is, a liquid mixture is an ideal solution. A liquid mixture is an ideal solution. A liquid mixture is an ideal solution if, this is the question actually. Options are given. Observe the question carefully. It will be understand to you. It obeys ideal gas equation. It obeys ideal gas equation. Then number two, it obeys Raoult's law at all concentrations. It obeys Raoult's law. At all concentrations. Then C, solute solvent interactions are similar. Solute comma solvent and solute solvent interactions are similar. Interactions are similar. So observe the question carefully. A liquid mixture is an ideal solution if, then three statements are mentioned. Then options look at. Then option A, A only. Then option B, A and B, A comma B. Then option C, B comma C. Then option D, C only. Option D, C only. So like this is mentioned in the question. Yes, observe the question carefully. So look, my dear students, liquid mixture is an ideal solution if it obeys ideal gas equation. Is that correct? Ideal gas equation, is that correct? So what is the ideal gas equation actually? The PV equals to nRT. This is applicable for only gases, right? Not for the solutions. So the first statement is wrong. First statement is wrong for the solutions. Then it obeys Raoult's law at all concentrations. So the solution which obeys Raoult's law at all concentrations, that is called ideal solution. So this is ideal solution, right? Next, the solute interactions, then solvent interactions. The solute solvent interactions are similar. Yes, exactly. So then only we call it as the ideal solution. So B and C, both statements are correct, right? So once both statements are correct, the C is the correct option for this. So based on the ideal solution in the previous years, they are given 3 questions. So remember, my dear students, that is very important. So next we have to discuss about the non-ideal solutions. In that 2 types will be there again. Positive deviation of non-ideal solutions and a negative deviation of non-ideal solutions. Then after, so azeotropic mixtures also is there. Then after, colligative properties also have to discuss based on the what type of questions they are given, that we have to discuss. So look, my dear students. So next we have to discuss that is non-ideal solutions. In that 2 types of positive and deviation non-ideal solutions, positive and negative deviation of non-ideal solutions have to discuss. Non-ideal solutions. Sir, which are the non-ideal solutions? So ideal solutions gurinchi manam discuss chesetappudu, so oka point mention chesam. Sir, what is that? This is solute and this is solvent. The both are present, solute and solvent are present. Sir, solute is B component, solvent is A component. Here in between the solute and solvent interactions are there. In between the solvent interactions are there. When both are mixed, a solution is formed. Right? Sir, solution is formed, then A and B both components are there. In between them interactions are there. The previous we have discussed about the ideal solutions. Sir, in between the A interactions, that is equals to B interactions, that is equals to AB interactions. Sir, what are A and B? So just assume that B is a solute, A is a solvent. So solute ki madhyana unna interactions, solvent ki madhyana unna interactions, rendu mix chesin tarvata solvent ki solute ki madhyana unna interactions similar ga unte దాన్ని మనం ఐడియల్ సొల్యూషన్స్ అని డిస్కస్ చేసుకున్నాం, రైట్? సో నౌ నాన్ ఐడియల్ సొల్యూషన్స్ ఆపోజిట్ టు ద ఐడియల్ సొల్యూషన్స్, రైట్? సో the solute interactions are not equals to solvent, solvent, and solute, solute. Then in between the solute and solvent also. Clear? So such type of solutions we call non-ideal solutions. We can say the statement that is the solution in which the solution in which the solution in which the solution in which solute, solute and solvent, solvent interactions are not equals to not equals to solute solvent interactions, solute solvent interactions. That is what I told. This is the statement actually. Then second one we can say very easily, that is the solution which does not obey the Raoult's law is called non-ideal solution. The solution which does not obeys Raoult's law is called non-ideal solution. Yes, up to here we can say so very easily, because both are opposite to each other, right? Then one more, mathematically the Raoult's law, nothing but what I told. Sir, Pa it is equals to P naught A into mole fraction of A. That is Raoult's law. Sir, solution which does not follow the Raoult's law, nothing but that are not equal. Pa it is not equals to P naught A into mole fraction of A. Then Pb it is not equals to P naught B into mole fraction of B, right? Then P total that is not equals to P naught A into mole fraction of A plus P naught B into mole fraction of B. So not equal, we can say the not equal. Clear, my dear students, up to the third statement it is. Then come to the fourth statement. The fourth statement, that is delta V upon mixing. Observe this very carefully. It is not equals to 0. That means what? Sir, I told that this is a 10 ml will be there. Just assume it. Even this is 10 ml will be there. Then you have to get 20 ml in case if it is ideal solution. But for non-ideal solution, it may be the solution, it may be 20.1 or 19.9. అంటే ఎగ్జాక్ట్ వాల్యూమ్ కంటే తక్కువ ఉండడం కానీ ఎక్కువ ఉండడం కానీ జరుగుతుంది. So such type of solutions are called non-ideal solutions. Then the mathematically one more, delta H upon mixing, enthalpy change upon mixing, that is not equals to 0. Enthalpy upon mixing is also not equals to 0. Then so one more sixth statement, that is delta S is always greater than 0, delta Z always less than 0. This won't change for the ideal and non-ideal solutions. Clear, my dear students? So these are the important points for the non-ideal solutions. So remember, non-ideal solutions are two types: the positive deviation of non-ideal solutions and a negative deviation of non-ideal solutions. So both we have to discuss now. While discussing about the ideal solutions, sir, one of the important point I told when we are discussing PYQs, which are example for the ideal solutions if they will ask a question. Remember, similar structure and similar geometry and similar polarity containing molecules are ideal solutions. Example for the ideal solutions. Note down all these points for the non-ideal solutions. So next we have to discuss about the positive deviation of non-ideal solutions and a negative deviation of non-ideal solutions. So non-ideal solutions are two types. Positive, one is positive deviation of non-ideal solution. One more, negative deviation of non-ideal solution. First, we have to discuss about positive deviation of non-ideal solutions. Positive deviation of non-ideal solutions. What are the positive deviation of non-ideal solution? Positive deviation, remember positive deviation, nothing but. So very simple, when solute and solvent, when it is added to both, the volume it may increases. When volume may increases, in between the solute and solvent interactions are weaker than that of solvent, solute. సరే ఏ బి ఇంటరాక్షన్స్ వీకర్గా ఉంటే దేనికంటే ఏ ఇంటరాక్షన్స్ కంటే బి ఇంటరాక్షన్స్ కంటే సరే వీకర్గా ఉంటే ఆటోమేటిక్గా వాల్యూమ్ అనేది ఇంక్రీజ్ అవుతుంది. సో రిమెంబర్ the solute and solvent interactions, the solution in which solute and solvent interactions are weaker when comparative to solvent interactions, solute interactions. Such type of solutions we are calling positive deviation of non-ideal solutions. So remember my dear remember my dear students, a solution in which solute solvent interactions are weaker. Than solute and solvent interactions are called positive deviation of non-ideal solution. Positive deviation of non-ideal solution. Understand my dear students what I am telling to you? Sir, A in between B, whatever the interactions are there, A, B, nothing but what? Say A is a solvent, B is a solute. So these interactions are weaker than that of A interactions than or B interactions. So such type of solutions we call as a positive deviation of non-ideal solutions. Then, sir, in case in the form of Raoult's law, if you tell, that is second one. Sir, P generally according to the ideal solutions, PA it is equals to P naught A into mole fraction of A, right? But here the PA value is a greater than that of expected from the Raoult's law. The PA is greater than that of expected from the Raoult's law. Each component, not only for this component, even the PB is greater than that of P naught B into mole fraction of B. Then automatically the P total is a greater than sir P naught A into mole fraction of A plus then P naught B into mole fraction of B. That you have to remember. P total are partial pressure of each component. P total are partial pressure of each components are greater than expected from the Raoult's law or calculated from the Raoult's law. That we are calling positive deviation of Raoult's law. Then remember my dear students, the third point is very important. Delta V mixing. The solute and solvent when it is mixing. Sir, in the both cases, the volume will be increases. I told that the previous solute is 10 ml, solvent is 10 ml. When both are added, we can get 20 ml exactly. That we call ideal solution. Sir, in case 20.1 ml or 20.2 ml, that we call positive deviation of non-ideal solution. So delta V mix is greater than 0, the positive deviation. So delta V mix is greater than 0, nothing but is a positive value we can get, positive value. Even one more, delta H mixing, nothing but what? Delta H mixing, nothing but what? The enthalpy upon mixing of solute and solvent is greater than 0, nothing but delta H mix equals to positive. Positive ante enti? Delta H value positive ga unte, then we call it is endothermic dissolution. Then we call it is endothermic dissolution. So this is endothermic dissolution we call. Understand, my dear students? Sir, all these points are belongs to the positive deviation of non-ideal solutions. Then here, one of the graph we have to represent for the positive deviation of non-ideal solutions. Then what are the example for the positive deviation of non-ideal solutions that we have to discuss in this case? See, once look at the graph first. Graph for positive deviation of non-ideal solutions and examples for the positive deviation of non-ideal solutions. Both we are discussing. So look at, so dear students, remember all these topics will be there in live chat, in the live session in my channel, the home page, then videos and shorts, then live. If you take live, so in the live all the videos are there. Nearly 20 lives we are discussing. The 20 live videos are there. So again, the topics we can listen. Then you can note it each and every question, whatever the concepts we are discussing, right? So listen carefully, it will be understand to you. So once look at first, we are taking graph for ideal solutions. Ideal solutions ki neeku graph arthamayindi ante, then automatically ga positive deviation of non-ideal solutions ki graph arthamautundi. So first two ideal solutions we are taking. See, look at, then here the graph we are taking on this, in the place of this, the mole fraction of A equals to 0. Then mole fraction of B equals to 1. So mole fraction of A equals to 1 here. The mole fraction of B equals to 0. So observe the question carefully. Sir, on this axis we are taking vapor pressure. So vapor pressure versus mole fraction first we are taking. Vapor pressure versus mole fraction first we are taking. So vapor pressure of A component versus mole fraction we are taking. The vapor pressure, partial pressure of A component is directly proportional to mole fraction of that particular component, right? According to the Raoult's law. Clear, my dear students? Listen carefully what I am telling to you. So at this point, mole fraction of A component is 0. Then while going like this, the 0.1, then 0.2, then 0.3, then 0.4, then 0.5, then 0.6. So up to 1, you can get 1. So in this direction, mole fraction of A increases. In this direction, mole fraction of A increases. Then mole fraction of A increases, partial pressure also increases, right? According to the Raoult's law. So you can get a straight line through the origin. At origin, mole fraction of A equals to 0. At origin, mole fraction of A equals to 0. So from the origin, it will increase like this. So at which point that will be cross this mole fraction of A, the mole fraction of B, where it is 0, that we call it as a P naught A, the maximum it is, maximum. Then once again, if you take from this, so ఇటు side నుంచి తీసుకుంటే, ఇటు side నుంచి తీసుకుంటే, mole fraction of B here 0 at this point. Then mole fraction of B, it will be start from the 0.1, 0.2, 0.3, 0.4, 0.5. Then mole fraction of B at this point is 1. So 0.1 నుంచి 1 వరకు ఇంక్రీజ్ అవుతా ఉంది, ఈ డైరెక్షన్ లో అది ఇంక్రీజ్ అవుతా ఉంది. సో అప్పుడు దెన్ B కి నీవు గ్రాఫ్ డ్రా చేస్తే then you can get like this. Sir, where it will be cut, that we call P naught B, P naught B. So this curve, what will be there, this line, what will be there, this straight line, it is belongs to PA, that is equals to P naught A into mole fraction of A. This line, the PB, that is equals to P naught B into mole fraction of B. Look, my dear students, observe the graph carefully. So when both dots, when it is added here, that is belongs to the P total, it is equals to PA plus PB. This is for ideal solution. Yes, clear all of you? What is the graph we are discussed, that is for ideal solution. Now we are discussing for positive deviation of non-ideal solutions. So look, my dear students, positive deviation of non-ideal solutions. So here we are taking the mole fraction of A equals to 0. Then mole fraction of B equals to 1. Then here the mole fraction of A equals to 1. Then here the mole fraction of B equals to 0. Then same ideal solutions, whatever the graph will be there, that we are drawing here. That we are drawing here. Observe the question. Observe that. Observe that. So we can get ideal solution like this. So this is P naught B. Then this is P naught A, right? Sir, here positive deviation of ideal solution I told. Sir, I told that PA is greater than that of, PA is greater than that of P naught A into mole fraction of A, I told. P naught A into mole fraction of A. So, in case equal will be there, we can get a straight line like this. So in case greater will be there, then we can get a curve above that particular line. So this is belongs to PA. So PA, it is equals to P naught A into mole fraction of A. Even for this also we can get above that particular line. Even the P total also we can get above the line. So this is belongs to PB, it is equals to P naught B into mole fraction of B. Then this is P total, it is equals to PA plus PB. So positive deviation you can get above the ideal solution of the line. So this is the graph is belongs to positive deviation of non-ideal solutions. So remember, my dear students, the example for the positive deviation of non-ideal solutions, if you take, then so which are where there is a repulsions, actually not interactions, where there is a repulsions in between the solute and solvent, all the molecules that you can get as examples for the positive deviation of non-ideal solutions. So note first these two graphs, then we'll discuss what are the positive deviation of non-ideal solutions are there. See what are the examples are there for the positive deviation of non-ideal solutions. Positive deviation of non-ideal solutions. Examples. Example for positive deviation of non-ideal solutions. So that is acetone plus ethyl alcohol C2H5OH. Then acetone plus carbon tetrachloride. Then acetone plus benzene. So wherever the repulsions are there in between the molecules, there is no attractions actually. There is no attraction. Such type of molecules, even the CS2 plus CCl4, then CS2 plus acetone. So all these are the example for positive deviation of non-ideal solutions. So wherever the more attractions are there, that we call the negative deviation of non-ideal solutions. Yes, listen my dear students, now we are discussing negative deviation of non-ideal solutions. Negative deviation. Next one. Next topic is negative deviation of non-ideal solutions. Yes, all these are opposite to the positive deviation of non-ideal solutions. Negative deviation it is. Negative deviation of non-ideal solutions. So which are the negative deviation of non-ideal solutions? A negative deviation where it will be there. Sir, wherever the solute and solvent, strong interactions will be present. Wherever the solute and solvent, strong interactions are present when comparative to solute-solute and solvent-solvent, such type of solutions we are calling negative deviation of non-ideal solutions. So note that, my dear students, the solutions in which the solutions in which solute solvent interactions are stronger than solvent interactions, solvent and solute interactions are called negative deviation of non-ideal solutions. Non-ideal solutions. What does it mean? Sir, solute and solvent A, B interactions are stronger than that of A interactions or B interactions. So A interactions or B interactions are weak than that of AB interactions. AB interactions are stronger than AA interactions and BB interactions. So such type of solutions we are calling the negative deviation of Raoult's law. Then one more. Then second point what we are discussing in it, according to the Raoult's law, then PA is less than that of P naught A into mole fraction of A. Then PB is less than that of P naught B into mole fraction of B. What does it mean? Partial pressure of each component and as well as P total is less than that of what we are calculated from the Raoult's law. Clear? So partial pressure of A component and B component, we can say the partial pressure of each component in the solution is less than that of what we are calculated from the Raoult's law, what we are expected from the Raoult's law. That type of solutions we are calling negative deviation of non-ideal solutions. The P total is less than that of P naught A into mole fraction of A plus P naught B into mole fraction of B. Look, my dear students. Then one more example, one more statement for this. Sir, in case delta V upon mixing, you can get negative, nothing but. So 10 moles, 10 ml of solute and 10 ml of solvent, when both are added, we can get generally, that is 20 ml, that we call ideal solution. But in case if you get 19.9 ml or 19.8 ml, then we call this negative deviation, less value, less volume. Volume will be decreases. So why volume will be decreases? Whenever interaction between the solute and solvent very stronger, when they are very close to each other, then space will be decreases, the volume will be decreases. That is what I told, delta V mixing, it is equals to negative. Then fourth one, delta H mixing, it is also negative. Then the fifth one, I told that delta S value, then delta Z value, it won't change. Delta S value always greater than 0. Delta Z value always the less than 0. Nothing but is spontaneous. Right, my dear students? So these all are negative deviation of non-ideal solutions. If you take graph for the non-ideal solutions, the negative deviation of non-ideal solutions, if you take a graph for negative deviation of non-ideal solutions, see graph for negative deviation, yes, for above one, non-ideal solutions. So here, according to the ideal solutions, how we can get the graph, right? So mole fraction of A at this point is 0. At origin, mole fraction of A equals to 0. Then mole fraction of B equals to 1. Then at this point, mole fraction of A equals to 1. Then mole fraction of B equals to 0. Sorry, 1. So look at here, from the 0 at this point to, from here, the mole fraction of A component will be increases. Once the mole fraction of A component increases, then partial pressure also increases. This is actually the pressure versus mole fraction. If you take the graph, you can get the straight line through origin, right? Because both are directly proportional. What I told, PA is directly proportional to P naught A, sorry, mole fraction of A. That is what I told. Then from this, PA equals to P naught A into mole fraction of A, right? So once where the touch the line, that we call it as a P naught A. Then if you take one more line from this origin, then here it is P naught B. So both when it is added, then we call it as P total. So negative deviation of Raoult's law. Sir, once expected from the Raoult's law, whatever it is there, the PA is less than that of P naught A into mole fraction of A, I told. Less value you can get, that means the curve will get below the ideal solution line. Then even here also you can get the curve like this. Even here also you can get the curve like this. So these are negative deviation of non-ideal solution graph. So what are the example for the negative deviation of non-ideal solutions? Sir, wherever the strong interactions are there in between the solute and solvent, their volume decreases, their exothermic dissolution takes place. That solutions are called a negative deviation of non-ideal solutions. So where the strong interactions generally, sir, wherever the hydrogen bonding is formed in between the solute and solvent, strong interactions will be formed. For example, sir, acetone will be there. Acetone, one of the example, acetone and chloroform CHCl3. See, look at here, acetone is a polar nature due to the presence of more electronegative oxygen atom. Then partially negative charge it can get on oxygen. Then here partially positive charge. So that is what poles will be produced in it. Then we call it the polar nature. Then chloroform, if you take, then chloroform, carbon, hydrogen, the 3 chlorine atoms it is attached at the carbon atom. So chlorine atoms all are more electronegative atoms. When it is attached to the carbon, electrons are withdrawing towards itself. Withdrawing towards itself. So where the electrons are withdrawing, then the partially positive charge will be developed on the hydrogen atom. So due to the attraction of electrons towards the chlorine atoms, then here in between the partially positive charge of hydrogen atom, a partially negative charge of oxygen atom, attraction forces will be formed. One of the interaction is formed that we call hydrogen bonding, right? Due to the presence of this hydrogen bonding only, we call it is strong interactions between the solute and solvent. Wherever the strong interactions are present in between the solute and solvent, that can form negative deviation of non-ideal solutions. Clear, my dear students? So generally in which type of solutions? A strong acid plus water can form negative deviation of non-ideal solutions. Remember, for example, H2SO4 plus H2O, HCl plus H2O, HNO3 plus H2O. All these are strong acids. Strong acids, when it is attached with a water, then strong attractions will be there. When strong attractions will be there, negative deviation will be formed. Then strong base, remember my dear students, strong base plus H2O will be present. Even at this case also, negative deviation of Raoult's law will be formed. So these are the examples. Even acetone and chloroform, the negative deviation of Raoult's law, that is the example for this. Clear? So note down the graph and as well as examples what we are discussing. Yes, my dear students. So next topic is azeotropes. Azeotropes. Yes, observe the topics carefully, my dear students. We are discussing very clearly each and every point what will be there in the NCERT textbook. That is useful for NEET also. So please follow my channel, subscribe my channel, share my channel, and also refer to those who are preparing for the NEET examination and EAPCET examination. So whoever your juniors or your friends or other college students, whoever is there, then refer to them. So join in the live or subscribe my channel so you can get a notification whenever we are taking live. So that is very useful. Those are preparing in the home in the summer sessions. Clear? So next we are discussing about the azeotropes. Azeotropes. So what are the azeotropes? Azeotropes is also called as constant constant boiling mixture. Boiling mixture. So what are the azeotropes or what are the constant boiling mixtures? I will explain very clearly to you people. Listen carefully. See, look at my dear students. One of the solution is there. It is a binary solution. Just assume it. So in the binary solution, A component is there and B component also is there. So it is present in the closed vessel. Even the vapors are formed in the space in between the liquid surface and above the cap. So even in this vapor state also A component is there and as well as B component is there. Sir, here A component, just assume it as 0.6 is the mole fraction. Then here 0.4 is the mole fraction. The composition of both we are given. Even in the vapor state, here 0.6, then here 0.4 will be there. Remember, a mixture of two or more components. A mixture of two or more components having same composition in liquid phase and as well as in the vapor phase and boils at constant temperature are called as azeotropic mixtures. Sir, if rendu ఒకే టెంపరేచర్ దగ్గర బాయిల్ అయితే then we call it as a constant boiling mixtures. Constant boiling mixtures. Once again, listen carefully what we are discussing. So liquid phase లో same composition ఉండాలి, vapor phase లో same composition ఉండాలి. A mixture contains two or more components having same composition in the liquid phase and vapor phase are called as azeotropic mixture. These azeotropic mixture can boil at constant temperature. That is what we are calling it as constant boiling mixtures. Clear, my dear students? Yes, note down the definition. So what we are discussing now, note down the definition. What we are discussing. A mixture of two or more components having same composition in liquid phase as well as in vapor phase and boils at constant temperature are called azeotropes. Remember, my dear students, azeotropes cannot separate by using fractional distillation. So even ideal solutions we can separate, the non-ideal solutions we can separate, but azeotropes cannot be separated by using fractional distillation. So note even that point. Azeotropes cannot separate by using fractional distillation. These are called azeotropic mixtures. So now azeotropic mixtures are two types: minimum boiling azeotropes and maximum boiling azeotropes. So two type of mixtures are there: minimum boiling azeotropes and maximum boiling azeotropes. That both we'll discuss now. What are the minimum boiling azeotropes and what are the maximum boiling azeotropes? I told that the azeotrophs are two types will be there. Minimum boiling azeotrophs. Minimum boiling azeotrophs. Then one more, maximum boiling azeotrophs. Maximum boiling azeotrophs. Minimum, maximum. So what are the minimum boiling azeotrophs? Minimum boiling azeotrophs ఏంటి? ఏవి minimum boiling azeotrophs? Sir, the solutions of both solute and solvent. The solution which can boil at the temperature below of both solute and solvent. That type of solutions we call minimum boiling azeotrophs. The azeotropic mixture which can source large positive deviation, the azeotropic mixture which can source large positive deviation, that we call minimum boiling azeotrope. So minimum boiling azeotropes ఏం చేస్తాయి? Large positive deviation can source large positive deviation can source from Raoult's law. So why these are calling minimum boiling azeotropes? For example, we are taking, that is ethyl alcohol C2H5OH plus water, both we are taken. Ethyl alcohol, water we are taken. Sir, ethyl alcohol, it contains 96.5%. This is 4.4%, like this will be there. Just assume it. So once both we are added, then we can get 100%, right? So 96.5, then 4.4 will be there. Sir, water boiling point is a 373 Kelvin temperature. Then ethyl alcohol boiling point is 351.3 Kelvin temperature. So ఇది boiling points of both. Observe the question carefully. Observe the topic carefully. ఈ రెండు మిక్చర్ని 96.5%, 4.4% రేషియోలో తీసుకుంటేనే at a specific composition, we call it as at a specific composition, these we call it as the minimum boiling azeotropes. So why we are calling the minimum boiling azeotropes? So when comparative to both boiling points, the mixture can be boiled below these two temperatures. అంటే అది 351 కెల్విన్ టెంపరేచర్ దగ్గరనే అది బాయిల్ అవుతుంది. అంటే ఈ రెండు టెంపరేచర్ల కంటే, ఈ రెండు బాయిలింగ్ పాయింట్స్ కంటే తక్కువ టెంపరేచర్ దగ్గరనే అది బాయిల్ అయితే దాన్ని బాయిలింగ్ పాయింట్ ఆఫ్ అజియోట్రోప్ అంటున్నాం. దీన్నే మనం మినిమం బాయిలింగ్ అజియోట్రోప్ అన్నాం. సో వాట్ అబౌట్ ద maximum boiling azeotrope, man? The solution which shows large negative deviation, the solution which shows large negative deviation, from Raoult's law is called maximum boiling azeotrope. So maximum, why we are calling? So for example, here HNO3 plus H2O will be there. HNO3 plus H2O. This is 68% will be present. This is 32% will be present. Then here 373 Kelvin temperature will be present. So here 368 Kelvin temperature will be present. But both boiling points కంటే హై బాయిలింగ్ పాయింట్ దగ్గర అంటే 374 కెల్విన్స్ దగ్గర ఇది బాయిల్ అవుతుంది. సో అలాంటి మిక్చర్నే మనం maximum boiling azeotropes. So azeotropes nothing but what we are discussing. The solutions in the liquid, the solutions having two or more components having same composition in the liquid phase as well as in the vapor phase. Such type of mixtures we are calling azeotropic mixtures. So azeotropic mixtures that must be contain the specific composition. That is what we are mentioned the percentages of both. So HNO3 68% unte H2O 32% undali. In case if you take this is 50%, this is 50%, that we are not calling azeotrope. So that at a specific composition, remember, at specific composition, at specific composition, at a specific composition, these are forms. Clear? So note down what are the examples are there for the azeotropes. Yes. So next we have to discuss about the colligative properties. The what are the colligative properties that we have to discuss? What are the colligative properties that we have to discuss? Colligative properties. Colligative properties. So what are the colligative properties? The physical properties of solutions. The physical properties of solutions which are depends upon only the relative number of solute particles but not nature of the particles are called colligative properties. The physical properties which are depends upon relative number of solute particles but not nature of the particles are called colligative properties. Colligative properties are four. So what are those? Relative lowering vapor pressure, elevation in the boiling point, depression in the freezing point, then osmotic pressure. Four properties are there. So what are those? What are the colligative properties? First note down the definition all of you. The physical properties of very dilute solutions. The physical properties of dilute solutions. Physical properties of dilute solutions. Physical properties of dilute solutions which are depends on number of solute particles, number of solute particles but not nature of solute particles. Nature of solute particles are called colligative properties. Colligative properties. Colligative properties. These are four types I told. So these are four. What are those? Number one, relative lowering vapor pressure. Relative lowering vapor pressure. Then number two, elevation in the boiling point. Elevation in boiling point. Number three, depression in freezing point. Depression in freezing point. So number four, osmotic pressure. Osmotic pressure. Remember my dear students, is very important. Colligative properties are directly proportional to the number of particles. So remember my dear students, but not depends upon the nature of the particles. Cp, just assume it as Cp, nothing but colligative properties that are directly proportional to number of solute particles, then that is directly proportional to number of ions, in case if it is electrolyte, adi electrolyte aithe number of ions. Then third one, it is depends upon, or it is directly proportional, all the colligative properties, man, all the colligative properties directly proportional to number of solute particles, directly proportional to number of ions in case if it is electrolyte, number of molecules in case if it is non-electrolyte. Then fourth one, number of or concentration of solute in it, in the solution. But only the thing is, that is fifth one, inversely proportional to gram molecular weight of the solute. Inversely proportional to gram molecular weight of the solute. Remember, my dear students. So whatever the points, number of solute particles, number of ions, then number of molecules, then what we have discussed, then gram molecular weight. So all these colligative properties all depends upon the number of particles. So remember one more very important point I will tell to you. Please stay in the line. Please stay in the live. That will discuss to, based on these important point. Many of the previous year questions also is there. So first one, that is, remember boiling point, then relative lowering vapor pressure, elevation in the boiling point, then depression in the freezing point, then osmotic pressure, the OP, just assume it as OP, osmotic pressure. So BP, boiling point, relative lowering vapor pressure, elevation in the boiling point, delta TB, then depression in the freezing point, delta TF, then osmotic pressure we can represent with a pi. All these are directly proportional to number of solute particles. Remember, relative lowering vapor pressure, boiling point, elevation in the relative lowering vapor pressure, elevation in the boiling point, depression in the freezing point, osmotic pressure. But only the two things, such as vapor pressure and freezing point, is very important. Vapor pressure and freezing point, remember, freezing point, not depression in the freezing point, not relative lowering vapor pressure, pure vapor pressure and freezing point, both are inversely proportional to number of particles. These are very, very, very important, ma'am. Very important for objective examination, because many of the questions they are given in the EAPCET examination. That we'll discuss now itself. Okay. So clear, all of you? Just note down these points. So which are very important to you. So note down, all of you. Note down. Satvika. Hi, sir. Yes, hi. Yes, look, my dear students, some of the questions which are very important based on all these 3 points. So సరే ఈ పాయింట్స్ మీద మీకు ఎలాంటి టైప్ ఆఫ్ క్వశ్చన్స్ ఇచ్చాడు అనేది నేను ఒక్కసారి మీకు డిస్కస్ చేస్తే ఈ పాయింట్స్ అన్ని మీరు నోట్ చేసుకుంటే. సరే బీపీ నథింగ్ బట్ వాట్, బాయిలింగ్ పాయింట్. ఆర్ఎల్విపి నథింగ్ బట్ రిలేటివ్ లోయరింగ్ వేపర్ ప్రెషర్. ఆల్ దీస్ ఫోర్ ఆర్ వాట్ మ్యాన్, కొలిగేటివ్ ప్రాపర్టీస్. ఇవన్నీ కూడా కొలిగేటివ్ ప్రాపర్టీస్. కొలిగేటివ్ ప్రాపర్టీస్ కి డైరెక్ట్లీ ప్రపోర్షనల్ ఉంటాయి. దెన్ వేపర్ ప్రెషర్ అండ్ ఫ్రీజింగ్ పాయింట్ కి ఇన్వర్స్లీ ప్రపోర్షనల్ టు ద నెంబర్ ఆఫ్ పార్టికల్స్ ఉంటుంది. దీన్ని మీరు గుర్తుపెట్టుకుంటే సరిపోద్ది. సరే ఈ 2 పాయింట్స్ ని బేస్ చేసుకుని చాలా క్వశ్చన్స్ అడిగాడు మనకు ప్రీవియస్ ఇయర్ లో. దాన్ని మనం డిస్కస్ చేయబోతా ఉన్నాం. దట్ ఈస్ ద ఫస్ట్ క్వశ్చన్. విచ్ ఆఫ్ ద ఫాలోయింగ్ సబ్స్టాన్స్ షోస్ హైయెస్ట్ కొలిగేటివ్ ప్రాపర్టీ? విచ్ ఆఫ్ ద ఫాలోయింగ్ substance shows highest colligative property? Highest colligative property. So look at the question. Highest colligative property. This is the question in the EAPCET examination. What they are given. So that is the question. Actually this question is given in the 2022 July 19th man. 2022 July 19th కడిగిన క్వశ్చన్ ఇది. సో వెరీ ఇంపార్టెంట్ క్వశ్చన్. ఆప్షన్స్ చూడండి ఒకసారి. సో ఆప్షన్స్ ఏమి ఇచ్చాడంటే, సో ఆల్ దీస్ ఆర్ 0.1 molarity of BaCl2 solution, then B, then 0.1 molarity of AgNO3 solution, then C, 0.1 molarity of urea, then D 0.1 molarity of NH4 taken thrice PO4. Yes, look at my dear students. I told that they are asking colligative properties. Colligative properties are directly proportional to number of particles. I told. Yes, I told or not? Number of particles. Sir, whatever the colligative properties are there, relative lowering vapor pressure, elevation in the boiling point, depression in the freezing point, osmotic pressure, all these are directly proportional to the number of particles. Even they are not specifically one colligative property, sort of just colligative property, which is highest they are asking. So here that BaCl2, it can be dissociated into how many number of particles, ma'am? Ba plus 2 plus 2Cl minus. The concentration is same for all, 0.1 molarity. But the particles, it is depends upon the particles here. The 3 particles are there total. If you come to AgNO3, sorry, Ag plus NO3 minus. The total number of particles are only 2 particles. Then if you come to urea, it won't dissociate. So the only 1 particle. Then if you come to here, so NH4 taken thrice, and the 3 moles of NH4 plus will be there, plus PO4 minus 3 will be there. The total number of particles are 4. So where the more number of particles are there? So here more number of particles are there. So that is the answer for this question. Understand, my dear students? So note down the question carefully. Who is that? Mohana. So urea formula, NH2C double bond O NH2, man. Don't you know the urea formula, right? Urea NH2C double bond O NH2. This is the urea formula. It won't dissociate or associate. So it is completely covalent compound. That is the reason it won't dissociate. Clear? Yes, note down the question. Then one more question we'll discuss based on the same concept. Yeah. Look at next question, ma. Look at next question. Yes. So this question is given in the 2021 August 2021 August 4th kadina question mein. The trend in the colligative properties for same concentration of the trend in the colligative property for the same concentration of BaCl2, MgCl2 and NaCl respectively. This is the question, man. The same type of question based on that. So what I told, the colligative properties are directly proportional to the number of particles. This point you have to remember, this point. So only for the two things, only for the two concept is inversely proportional, the remaining all concept directly proportional. What are the two things? Vapor pressure and as well as freezing point. It is inversely proportional to the number of particles. Remaining అన్నిటికీ కూడా colligative properties ఏవైతే ఉన్నాయో సో వాటన్నిటికీ ఇది directly proportional గా ఉంటుంది. So remember, so now what are the options are there? That all options will note it now. So option A is mentioned. MgCl2 is greater than NaCl than BaCl2, like this is mentioned. Then B, NaCl is greater than BaCl2 than MgCl2 is mentioned. Then C, MgCl2 it is equals to BaCl2 less than NaCl, like this is mentioned. Then D option is mentioned. MgCl2 it is equals to BaCl2 is greater than that of NaCl is mentioned. Observe the question carefully. So these two options you can observe carefully. Sir, here less than NaCl is mentioned, here greater than NaCl is mentioned. So I told that colligative property is directly proportional to the number of particles. Whatever the components are given, that is MgCl2, then one more BaCl2. Sir, MgCl2 can be dissociated into Mg plus 2 plus 2Cl minus. The total number of particles are 3. Yes, for these 3 particles. Of course, BaCl2 also, Ba plus 2 plus 2Cl minus. The number of particles are 3. Sir, of course, even for this also 3. Then NaCl, particularly NaCl, it contains Na plus Cl minus, only the 2 particles. So it is greater than both. Both are equal because both are having the same number of particles. Clear, my dear students? So this is the correct option when compared to the remaining 3. Understand? Yes. So note down the question. One more last question will be there. Yes, all these are exams questions, man. Exams questions only. The previous year EAPCET examination questions. Yeah, one more question. Look at my dear student, one more question. The freezing point of equimolar aqueous solution will be highest for the freezing point of equimolar aqueous solution will be highest for will be highest for? This is the question. Get the question. This question is given 2020 September 10th. 2020 September 10th కి ఇచ్చిన క్వశ్చన్. ఎస్ సార్ ఆప్షన్స్ ఇచ్చాడు. ఆప్షన్ ఏ దట్ ఈస్ BaCl2. ఆప్షన్ బి CaNO3 taken twice. Option C again urea formula NH2C double bond O NH2. This is urea. Then D, that is Na2SO4. Sir, observe the question carefully, my dear students. Sir, adigina question not about the colligative property. It is for freezing point. I told that colligative properties ki maatrame directly proportional ga untayi number of particles ki, but only freezing point and as well as vapor pressure ee renditki inversely proportional to the number of particles ki inversely proportional ga untayi. So ikkada adigindi freezing point, the highest freezing point for which of the following solution, which of the following equimolar ante same molarity, equal molarity unna solutions. Then aqueous solution anni kuda water lo unna solutions. Clear, my dear students? Right. So here the number of particles are 3, that are Ba plus 2 plus 2Cl minus, total number of particles are 3. Then this is Ca plus 2 plus NO3 and 2NO3 minus, total number of particles are 3. Then urea, I told that it won't dissociate, only one particle will be present. ఇది dissociate అవ్వదు, ఇది ionic compound కాదు, ఇది covalent compound. Then Na2SO4, it can be dissociate because of ionic compound 2Na plus SO4 minus 2. The total number of particles are 3 here. Here 3, then here 3, then here 3. Sir, where the less number of particles are there, that is having more freezing point, highest freezing point, because inversely proportional. Less number of particles, more freezing point, highest freezing point. That is why urea is the answer for this. Okay, my dear students. So these are the questions. They are given in the examination based on this. The remaining colligative properties are there, that are elevation in the boiling point is there, depression in the freezing point is there. Based on these, numerical problems are there, that we'll discuss tomorrow. Please subscribe my channel and share my channel to your friends and relatives. Those are preparing for EAPCET examination in the home. Those cannot take coaching either in the short term or long term. Better to see everyday live session in 8 to 10 o'clock or 8 to 9 o'clock or 8 to 9:30. Okay, clear? So 8 o'clock it will be start. Please share and subscribe and like it, all of you. Yes, exactly, urea. Okay. Thank you, my dear students. Thank you, Mohana Kanuri. Thank you. Please join every day in the live session, and please subscribe my channel and share to your friends also. Okay. What? Your friends are cheating. What they are cheating? So from where you are, man? You are from? Okay. VZM. Nothing but Vishakhapatnam, right? Or Vizag? Vijayanagaram. Okay, okay. Okay, right. Okay. Okay, thank you. Thank you. So share to your friends also. Tell them every day come and live, come and join in the live session. Yeah, 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 yeah. Yes, exactly. APCET examination. So that's what. Okay, thank you. Thank you. Thank you. I will stop the live session. Okay, bye. Okay, okay, okay. Thank you.